So, yeah, my name's Greg Sutcliffe. I work for Red Hat. I work on a project called the Foreman. And I'm going to show you a little bit this morning about a feature we're working on. But first, I'm going to talk a little bit about Foreman. Just for my info, who already knows a bit about Foreman? Who's tried it, used it, played with it? Okay, about what I expected, about half the room. So, anyone who's seen a Foreman talk has seen this slide. We all use it. And so for the people who don't know what Foreman is, basically it's a provisioning and infrastructure management project, in which we try and get into the areas that other configuration management tools don't give you. So that's things like getting the OS onto the metal, it's spinning up cloud instances, it's getting certificates into your configuration management system. So it's all about the pre-installation, OS management, configuration, and then also helping your configuration management, providing data to it, so that's drift management, auditing, and so on. So it gives you, it has has a lot of components to it, a lot of moving parts, and I have to cover something in about 4 minutes that most people take an hour over. So, but yeah, so we tie into DNS, we tie into DHCP, TFTP, PXE, we try and get all of the provisioning stack in one place so that you can just spin up a machine in a couple of clicks and all of the operating system provisioning is taken care of for you. We support loads of operating systems. We support lots of different types of machines, so real hardware, cloud stuff, EC2 Rackspace, local virtualization on libvirt or revm or overt. So it's about trying to get one workflow for all of your stuff. And it also configuration management, so reports, audits, etc. So if you don't know what Foreman is and you want to know more about this, I've got some links at the end. You can find out more, but unfortunately the rest of this probably won't make a lot of sense. So this is lovely, right? We have this management. It's all fantastic. Not quite. If you've just had a delivery of 50 servers, you've got to go and type those MAC addresses in by hand. And no matter how good your monkeys are at typing in MAC addresses, there's going to be a typo somewhere. You're going to make a mistake, and you won't know that. And in a week's time, you'll try and provision that machine, and it won't work. And you'll make this face, obligatory lolcat picture. You'll make this face because it won't work, and you'll be like, but this is simple. Every other server works. All the MAC addresses work. Everything's fine, right? 2 hours later, when you've finished with your DHCP logs and your TCP dumps, and you find that you made a typo 2 weeks ago, you're going to be annoyed. So there's got to be a better way to handle real metal. You know, cloud we don't care because the MAC addresses are given to us. libvirt we don't care, the MAC addresses are given to us. But just this one time for real physical hardware, we don't want to have to do that work. So this brings us on to the metal as a service model. How does it work? So before we go on how to Foreman do it, just general sort of overview of metal as a service. The idea is that you make a distinction between hardware you know about and hardware you don't know about. So you make sure all your unknown hardware, machines you've never seen before, you boot them to some separate system. So you can do this very easily with PXE or iPXE. You can do it slightly more complicated ways as well. But the core concept is always the same. Boot your unknown hardware into some kind of RAM disk where it can register itself with a central system. And then it sends all its information, what's my hardware, it sends it up. Your central system knows about it, and then you as an admin can go and query that hardware, and you can say, okay, I need a new web server, give me something with 500 gig of disk and 24 gig of RAM, or whatever I've got, right? And then you maintain the system, it's a known system, it boots off its local drive, everything's good, and when you're finished with it, it doesn't need to be a web server anymore, you delete it, it boots back up off the RAM disk and comes back into the pool. So we map Foreman onto that reasonably closely. We have a PXE image that's based on Tiny Core Linux at the moment. We're still looking at exactly what the final image should be. But yeah, it works pretty well. It boots up, it queries itself, it finds out what hardware it's got, and it registers itself into Foreman, which is great. Get all the hardware data, get all of the things you need to know about the system. And then we have a page where you can view all of that data. You can tell it to refresh if you're missing, if you think it's out of date. I mean, hardware doesn't change very often, right? But still, it's there. And you can provision it. So that will send a signal back to the hardware, reboot into the installer, you know, Anaconda, pre-seed, whatever. So what I'd like to do at this point is a demo. However, demos in Lightning Talks are really, really risky. Also, the demo of a provisioning system generally takes longer than 15 minutes. So what I have, I'm going to talk you through the workflow. I have some screenshots that I did a few days ago. I'm also around for the rest of the day, so I'm going to hang out at the Overt booth later on. I'll probably be wearing that hat. So if you want to see the demo or you want to talk about any part of Foreman, you can come see me there. So this is a VM. It's a VM because that way I can take the screenshots, but in reality you'd be thinking of this as a real physical server. And you can see it's booted up. Foreman has no concept that this machine has ever existed before. And we've got a Pixie image. It comes up, it boots up, and Pixie says, well, I don't know who you are, so you're going to boot this discovery image. And once it's booted, you can see it's Tiny Core Linux. It says so in the bottom corner. We've got, the reason I've got this bit at the bottom is so you can see the MAC address. So I'm just going to, the last two characters are 0A if you can't read it, but that's just there so you can see the flow through the rest of the screenshots. So we've got an IP address, we've got a MAC address, it's all come up. In Foreman, some new buttons. So again, if you've not seen the Foreman interface, the hosts page is something we see very often. And there's a new button here in the top right called Discovered Hosts, all the way up there. If you click that, you come through to this pool of hardware information. You want to see all the servers that have registered themselves. So in reality, in a real infrastructure, you probably have quite a long list. Obviously, I've only got one because it's a VM. But again, it's the same MAC address. We've got 0A. We can tell that it's KVM. You can tell that it checked in a long time ago. So I could, if I wanted to, click that refresh fax button and just check the system's still online, make sure that I can, if I try and provision it, it will actually work. So I could click through onto, so you can see that the MAC address is actually a link, so I can click through and I can find out more about this host. And this probably doesn't come out very well, but you can see a few things down the bottom. We've got how much memory we've got things about the architecture, interfaces. We know about the system, right? So we can find out if this is something we want to use. And once we've got a host we're happy with and we want to provision this, turn it into a database server, whatever, we've got a button up there, provision. And that brings you onto the edit page. So this is actually three separate screenshots kind of merged together because the edit page has quite a lot of tabs on it. So on the left, we've got to give this a name. We can give it host groups, environments, all that good Puppet stuff. We've already got the MAC address and the IP address filled in for us on the top right because we know that. Well, the hardware's already running, so we can fill that information in, and we can choose an operating system for it. So, yeah, Fedora 17 or something. So as soon as I hit submit on that edit page, it's going to come through. It's going to send a signal to the hardware. It's going to reboot it. In this case, I was doing Debian. Oops. So it boots back up. It comes up. It goes into the installer. We get a nice partitioning information. If you're watching the screen, right? I mean, with real hardware, you'd never go and plug a monitor in just to check it's working, but just to show it's there. And so that's going to take, obviously, a while. That is why I didn't do a demo, because OS installs take like 20 minutes. And eventually it comes up, it becomes a real host. So this is a screenshot from the host page in Foreman. Again, if you've not seen it, we get nice graphs, we get information on the left. Again, you can see the same IP address, same MAC address, it's the same machine, and it's all flowing through and becoming a real host. You can manage it, you can look after it, drift, audits, all that good stuff. And eventually when you're done with it, you can hit that delete button. Oh, and just to prove a point, although it doesn't come out very well, that's the actual name of the machine from the libvirt console. It's come back up with the right name. Everything's good. When we're done, we hit that delete button in the top right-hand side, reboot the system. It's going to go straight back into that discovered host page. We can use it again for another role. Give it a new host name, reprovision it with a different OS, whatever we want to do with it. So that's kind of where it's at right now. This is a feature that's likely to be coming later this year, I think. Hopefully. We're not very good at releasing very quickly in Foreman. But it can be played with. There's details on our mailing list of how you can get this up and running right now if you want to play with it. It's very alpha. We've got some more stuff that needs to happen. So we need more hardware data on that fax page. That's something we've actually, some of the community members and I were hacking on a few days ago. So we've actually got the disk structure, or at least the total amount of disk space is now properly displayed, so that's good. We want to add filtering. So again, if you're familiar, you can search for hosts in Foreman. So we'd like to add the same kind of search functionality. So you can say, show me all the hosts that have got more than 500 gig disk or more than 24 cores or something. So that needs to be in there. And we'd quite like to do a kind of quotering system. There are other metal as a service products that are coming together. Some of them do a kind of a quotary system where you say, the first 20 hosts that come up that match these criteria, I want them to have Fedora on it with this disk structure. So that would be quite cool, I think. So you can kind of auto-provision the next lot of hardware that gets shipped. And OK, you might be in bed, but the systems are still built, right? Some things I'd quite like to... So this is kind of a fairly solid roadmap. These are things we'd like to do. These are a couple of things I thought of while I was writing the talk. I'd quite like to see whether you could just have some tick boxes. If I need to provision 10 web servers, I don't want to do them one at a time. So it would be quite nice to just tick, 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 provision, give it some kind of regex for the hostname. And I think that USB or Pixie boot image could be made so that you can load more code into it, maybe send it some custom facts, send it some extra plugins. One of the things that we've been talking about is how you've got a system that's sitting there running a RAM disk. So why don't you use this for hardware RAID configuration or BIOS updates or firmware updates or something like that. So there's a lot we could do with the actual image itself. What we got? Okay. So that's kind of the total of the talk. There's a lot more information about Foreman. It's a huge project. An hour wouldn't do it justice. But if you want to know a lot more about it, there's a video by one of my colleagues, which is superb. We've got all our community mailing list. We're very, very active on IRC, so do come and talk to us. And yeah, I guess I'm done. A little bit early. I should also say again, I will be at the overt stand for most of the day. So.
Yeah, if there is any question, that's fine because we have a little bit of time. Since anybody gave me any microphone, you will probably need to come here in order to.
I can repeat the question.
Ah, perfect.
Okay, so the question is, how do you deal with a really large amount of hardware, like 1,000 machines or something like that? I can think of a few problems with that. It might be quite a lot of load if you boot them all up at the same time. That could be interesting. I think that would work, provided the requests don't get lost somewhere. If you try and provision 1,000 machines at once, you're going to stress your Pixie server, that's for sure. But in terms of how Foreman would deal with it, I don't think it's too bad. We want to add filtering to this, so you can say, right, give me all the machines in this data center, and then give me all the machines in this data center that are Dell and have this much memory, right? So you can pick out exactly the sort of hardware you're looking for.
How does it relate to Puppet's Razor? I saw it on a screenshot too.
So, well done, you spotted the deliberate mistake where I was meant to talk about the other people who are doing metal as a service, right? So there's a few people who are doing it, Ubuntu are doing it, Puppet Razor are doing it. We started out looking at Razor. We contributed some code to them, which was quite useful while we were working out exactly how to do the discovery image. Our image is built in a very similar way to the Razor image. They have a different way of looking at templating to us. So it is possible to make the two work on the same network at the moment. It's a little bit... It's a little bit fiddly in places. You can have sort of Foreman on one virtual machine, say, and Razor on another virtual machine, and have it all kind of managing the network together. It does work. But realistically, they're both provisioning products, right? So why would you have two? No more? Okay.